Welcome to another Education Friday, everyone. I know if you've been here, you already know the vibe. This isn't a lecture; it's a conversation. And if it's your first time, of course, you just stepped into the one of the best growing spaces to actually understand Web3 without the noise that we already know. What we have on the table today? We'll be breaking down Ethereum, not just the headlines, but the real mechanics. Where it all started, how it actually works, where it's heading with proof of stake and scaling. Those buzzwords that we all hear. Now let's make sense of it all. But first, let me introduce, like for the first time, we all know Yusuf, but let me introduce him. He's an absolute expert in blockchain and someone who lives and breathes Web3. I know that from an experience, let's say. If you've got questions, he's the guy to ask. Whether in the live sessions today or in the discussion or in the chat, Discord, Telegram, wherever you want. And trust me, he's got insights that will make Ethereum click in ways you haven't thought about before. You know that already. So, as usual, our quick ground rules so we keep things smooth. There's no such thing as a bad question. If you're curious, ask away. That's why we're here, let's say. Drop your thoughts in the chat. Like you always, get an opinion, challenge something. We are here to discuss. And if you want to speak, you got the hand raise. So we'll get you in. Also, don't stress if you miss something or anything. The session is recorded and it will be sent to you like every time. So, Yusuf, if we are ready, let's get started, sir.
So thank you very much, Emin. First, let me present myself once again. So my name is Yusuf, and I work at DAR Blockchain as a software engineer specialized in game development and blockchain and cryptocurrencies. So welcome everyone to another exciting session of Educational Friday. It's fantastic to see many of you here, ready to learn, connect, and innovate. First, let me remind you again, guys, that DAR Blockchain is offering a free EDERA certificate, as we discussed last session. So this certificate will allow you to apply for jobs within the EDERA Hashgraph Association and the EDERA ecosystem at all, but also in the Web3 space. So by getting this certificate, you will gain valuable skills in smart contracts development, blockchain knowledge, and also like Web3 knowledge at all. So if you want to pass this certificate, I will paste the link in the chat, and you need to get over 70% so that you can get the EDERA certificate. Okay. So next slide, Anas, please. So today we are deeping dive into one of the most transformative ecosystems in the blockchain space, Ethereum. Whether you're a developer, investor, or simply curious about blockchain, this session will provide valuable insights into how Ethereum is shaping the future of decentralized applications, finance, and beyond. So as we move forward in our discussion, can you go back in the first slide, please? So as we move forward in our discussion, we now enter chapter 3. So to guide our deep dive, we will cover several essential areas, a high-level overview of Ethereum, providing context on what it makes it unique, the fundamental architecture and key concepts that define its functionality, real-world decentralized application dApps and use cases, a look into Ethereum's evolution highlighting its major milestones and technological advancements. Finally, for those looking to getting involved, we will cover how to get started and key considerations before diving into the ecosystem. To wrap up, we will also preview research topics for our next session, ensuring you to leave with valuable insights and directions for deeper exploration. So to truly understand Ethereum and its impact, we need to go back to its origins, where it all began and why it was created. Blockchain technology started with Bitcoin, which introduced the word to decentralized and trustless transactions. But one visionary saw potential beyond simple payments. So his name is Vitalik Buterin. So as a young programmer and co-founder of Bitcoin magazine, Vitalik became fascinated with cryptocurrencies in 2011. He recognized that while Bitcoin was revolutionary, it was limited in its functionality. Rather than modifying Bitcoin structure, he envisioned a new blockchain, one that was programmable, flexible, and capable of running decentralized applications. So if we deep in more into the timeline, in 2013, Vitalik published the Ethereum white paper, outlining a vision for a blockchain that could support smart contracts, self-executing agreements without intermediaries. By 2015, Ethereum's mainnet officially launched, introducing a new era of blockchain technology that enabled not only financial transactions, but also complex and decentralized applications across various industries. So Ethereum has since evolved into one of the most influential platforms in the blockchain technology. When we think of blockchain, the first thing that often comes to mind is Bitcoin, a decentralized currency that changed the way we perceive money. But Ethereum took this concept a step further by introducing programmability, making blockchain more than just a financial ledger. Ethereum is designed to support smart contracts. As I said before, self-executing agreements written in code. This means developers can build decentralized applications, what we also call dApps, that automate processes, remove intermediaries, and enable innovation across various industries, from finance, gaming, to supply chain management. Unlike Bitcoin, which mainly serves as a digital currency and store of value, Ethereum provides a framework for decentralized systems. This flexibility has fueled groundbreaking developments such as decentralized finance, so a new financial ecosystem without traditional banks, also NFTs, non-fungible tokens, a revolution in digital ownership impacting art, gaming, and real-world assets. Ethereum's programmability has opened doors to countless possibilities, shaping the future of blockchain technology. Next, we'll take a closer look at Ethereum architecture and key concepts, breaking down how it all works under the hood. So when discussing blockchain technologies, two names always come up, Bitcoin and Ethereum. While both are revolutionary, they serve very different purposes in the world of decentralized finance. So Bitcoin is called store of value, digital cash. So as we said in our first session, Bitcoin was the first cryptocurrency designed as a peer-to-peer electronic cash system, as the title of Satoshi Nakamoto's white paper says. Over time, it has earned the title of digital gold because of its focus on security, scarcity, and decentralized value storage. Its primary function is simple yet powerful to provide a reliable borderless means of transferring wealth. With a limited supply of 21 billion Bitcoin, it is seen as a hedge against inflation and a long-term store of value. Now, Ethereum takes blockchain technology beyond payments by introducing programmability. ETH is not just a currency, it's the fuel of the Ethereum network, paying for gas fees to execute smart contracts and run decentralized applications. This unique function incentivizes developers and users to contribute to the ecosystem. Up next, let's break down Ethereum's architecture and key components to understand how it all works. So one of Ethereum's most groundbreaking innovations are smart contracts. So the foundation of its decentralized ecosystem. These contracts are what make Ethereum truly unique, allowing code to execute transactions automatically without intermediaries. So what is a smart contract? At its core, a smart contract is a self-executing contract where terms are written in code. Instead of relying on third parties like banks or lawyers, these contracts run directly on the Ethereum blockchain and execute only when predefined conditions met. So smart contracts introduce 4 key benefits that revolutionize traditional agreements. Automation. Transactions execute instantly once conditions are fulfilled, reducing delays. Security, so being tamper-proof, smart contracts eliminate the risk of fraud. Efficiency, no need for manual processing, ensuring and also reducing costs and time. And finally, transparency, the contract code is publicly verifiable, ensuring trust among users. So next. Yes. If smart contracts are the foundation of Ethereum, then the Ethereum virtual machine, EVM, is its beating heart, the system that makes everything work. So without the EVM, Ethereum would simply be another blockchain. So let's break down what is the EVM. So the Ethereum virtual machine is a decentralized runtime environment responsible for executing smart contracts. It ensures that every Ethereum node processes transactions in a perfect synchronization, maintaining security and consensus across the network. The EVM plays a critical role in Ethereum's functionality and security by enabling standardization, supporting multiple programming languages, making Ethereum accessible to developers worldwide. So we can mention, for example, Solidity or Rust. Security by isolating contract execution to prevent malicious attacks from affecting the border network. And finally, determinism by ensuring that all Ethereum nodes produce the same result when executing smart contracts, preventing discrepancy. So next we'll break down the Ethereum architecture and key concepts, but this time with gas fees. So I'm sure that all of you have heard about the word gas fees. So when using Ethereum, one term you'll frequently hear is gas fees. But what exactly is gas and why does it matter? Just like a car needs fuel to run, Ethereum transactions require gas to be processed. Whether you're sending ETH, executing a smart contract, or interacting with a decentralized application, gas fees ensure the network runs smoothly and securely. So gas represents the computational effort required to process transactions and execute smart contracts on Ethereum. It's measured in GUI, a fraction of ETH. Gas fees are paid in Ether to reward network validators or stakers in the proof of stake system. Why do gas fees exist? So gas fees serve three critical purposes. The first one is to prevent spam. So since users must pay for transactions, gas fees reduce network congestion and prevent unnecessary or malicious activity. It also allocates network resources. Transactions with high gas fees get processed faster, ensuring efficient use of blockchain resources. And finally, stakers who secure and validate Ethereum transactions earn gas fees. So it incentivizes decentralization and security. Next, we will talk about decentralized applications and their use cases. So imagine a world where applications run without a central authority, no single company controlling the data, no middleman taking fees. That's the power of decentralized applications, or as we usually call them, dApps. These applications run on a blockchain rather than a centralized server, offering a new way to interact with digital services securely and transparently. So now let's give a definition to a dApp. So a dApp is an application that utilizes smart contracts to automate processes and remove intermediaries. Unlike traditional apps, which rely on central servers, dApps run on Ethereum's decentralized network, making them resistant to censorship and downtime. So what makes dApps unique? They have four defining features. First, decentralization. So no single entity has control, ensuring greater autonomy for users. Second, transparency. Every transaction and process is recorded on the blockchain, making dApps trustworthy and verifiable. Third, we have security. So operating on a decentralized network reduces vulnerabilities to hacking and data breaches. And fourth, we'll talk about incentivization. So many dApps use tokens to reward users, developers, and contributors for participating in the ecosystem. Next, we will cover the real-world use cases of dApps. So now that we understand what decentralized applications are, let's take a look at how they are being used in the real world. From finance and gaming to art and lending, dApps have revolutionized multiple industries by removing intermediaries and creating trustless ecosystems. So some key DeFi applications include Uniswap, which is a decentralized exchange that allows users to swap cryptocurrencies without a centralized authority. Aave and Compound, for example, are peer-to-peer lending and borrowing platforms where users can earn interest or take loans without banks. We can also talk about NFTs that have transformed the way we own and trade digital assets. Unlike cryptocurrencies, NFTs are unique, verifiable, and cannot be replicated, making them perfect for art, gaming, and collectibles. So some leading NFT platforms include OpenSea and Rarible, which are both marketplaces for digital art and collectibles, allowing artists to monetize their work directly. We can also talk about Axie Infinity, a play-to-earn gaming platform where users use NFT-based characters to battle and earn rewards. So next, we'll explore Ethereum's evolution and what's ahead for the ecosystem. Yeah, we can also talk about the supply chain management. In the examples here, we have VeChain, which tracks goods and verifies authenticity, and also IBM Food Trust. So they use blockchain for food and supply chain traceability. So supply chain management is also a use case that decentralized application can cover. So yeah, we can move on next. So as I said, now we will explore Ethereum's evolutions and what's ahead for the ecosystem. So we have seen how decentralized applications have transformed the world of finance and digital ownership. So Ethereum has undergone one of the most significant upgrades in blockchain history when they transitioned from proof of work to proof of stake. So in the early days, Ethereum was a proof of work coin, just like Bitcoin, okay? But why this change was necessary, and how does proof of stake improve the Ethereum ecosystem? So Ethereum moved to a proof of stake coin, first because it reduces energy consumption by over 99%. Second, proof of stake allows for more transactions per second, preparing Ethereum for future upgrades. We can also mention that proof of stake lowers the risk of centralization and makes 51% attacks much harder. So Ethereum moved to a proof of stake coin in 2022. We called this event the merge. So it was Ethereum's biggest upgrade, officially transitioning from proof of work to proof of stake, making staking the new method of securing the network. So instead of miners, Ethereum now relies on validators who participate in securing the network through staking. So validators look up ETH as collateral to propose and verify transactions. We can also talk about validator selection. So how does it happen exactly? Validators are randomly chosen to validate new blocks, eliminating the need for energy-intensive mining. Finally, we can also talk about rewards and penalties. So honest validators earn staking rewards, while malicious actors risk losing their staked ETH. We call that slashing. Okay, now let's move on and talk about Ethereum scalability solutions. So Ethereum is a powerful platform, but as adoption grows, so do its challenges. High transaction fees and network congestion have long been issues, leading to the need for scalability solutions that we will break down right now. So Ethereum and the major cryptocurrencies aim to solve what's known the scalability trilemma. So the challenge, so the trilemma is the challenge balancing decentralization, security, and scalability. Layer 1 alone cannot handle the increasing demand. So by layer 1, for example, Ethereum is a layer 1, Solana is a layer 1. Also, I don't know, Cardano is also layer 1. I'm just giving examples. So which is why we need layer 2 solutions to play a crucial role in scalability. So layer 2 solutions help Ethereum process transactions more efficiently while maintaining security and decentralization. So let's look three major approaches. Here we have rollups with optimistic and ZK rollups. So this processes transactions off-chain and submit compressed summaries to Ethereum, reducing costs and congestion. We can also mention sidechains, for example, Polygon. So sidechains are independent blockchains that connect to Ethereum, allowing faster and cheaper transactions, while benefiting from Ethereum's security. Finally, we have state channels. So state channels enable instant off-chain transactions with periodic on-chain settlement, improving speed without compromising decentralization. So now we will look on how to get started with Ethereum by setting up an Ethereum wallet. So just to remind you guys that this is not financial advice. It's only for educational purposes. I'm not here to give you financial advice. Okay, so before you can start using Ethereum, you will need a wallet to store, send, and receive ETH to interact with decentralized application dApps like Uniswap. Thank you for the comment, Medemin. Ethereum wallets come in two main types, each serving a different purpose depending on how you plan to use Ethereum. So first we have the hot wallets. So hot wallets are software based. Hot wallets are like are digital wallets that are connected to the internet, making them ideal or frequent transactions and dApp interactions. So popular hot wallets include MetaMask, Trust Wallet, Rainbow Wallet, Exodus, and Phantom. But there are also many other Chrome extensions and web applications that I haven't mentioned. So mainly hot wallets are the best for frequent transactions and dApp interactions. Okay. Second, we have cold wallets. So cold wallets, unlike hot wallet, they are hardware based. Okay. So for those prioritizing security and long-term storage, cold wallets are offline devices that protect your ETH from hacks and phishing attacks. Okay. So we can mention, for example, Ledger, Trezor, OneKey, and Tangem. So they are well-known hardware wallet options. So since they are not connected to the internet, they greatly reduce security risks. Regardless of the wallet type, security should always be your top priority. So with that, it's always important to store private keys and seed phrases securely. You need to write them down offline and keep them in a safe place. So don't keep them in your desktop or any social media application. You should also never share your private key or seed phrase to anyone, because if you share your private key or seed phrase, it means that you will lose access to your funds permanently. Another way is to enable two-factor authentication where possible for extra security. For example, Google Authenticator. Finally, I recommend to use a strong password combination and avoid using the same password for multiple platforms. So right now I will call Anas. So Anas is an intern at Dar Blockchain, and he's the Discord builder. So we'll try to set up a MetaMask wallet for Anas. So Anas, if you can go to Brave, yes, or...
Hello everyone. So what should I do now?
Okay. So right now you just need to open Google Store and download the extension.
I'm using Brave. So
Yes, no problem.
it's the same. Okay,
Yeah.
Chrome Web.
Chrome Web Store, yeah, exactly.
Okay. What to do now?
Okay, now you need, create a new one. So first you need to set up a password.
Should I do this or this?
You should always secure your wallet.
Okay.
So yeah, the second one, the recommended. So yeah, you can. No need to show us your private key, as I said.
I think I have to say it because it shouldn't pass, but this is just a test, so I guess it's not a problem. But for them, yeah, they shouldn't
I was
do
going
it.
to tell you to just stop the screen share, but it's okay. If it's only for a test, you can show your seed phrase. So, guys, the seed phrase of MetaMask is usually composed of 12 words. So, as I said, you need to write them down on a paper rather than copying them and storing them on your desktop or any other social media platform. We can go on. If you have any question, guys, you can write us on the chat. So don't share the phrase. I think you can reset it. Okay. Great. So now we have successfully installed MetaMask. So at the top left, as we can see, we have Ethereum mainnet, but you can also switch to another blockchain. Yes. Okay. So I have a question for you guys as we are moving on with the discussion. Earlier, I talked about layer 2s. So who can quickly tell me which one in the list here is a layer 2 solution from what is Anas is displaying? So yeah, Arbitrum, that's right. What else we have? Okay, Polygon, yeah. I mentioned that in the presentation. That's right also. We also have another one that I mentioned. Yes, Optimism. That's right. Absolutely, guys. Optimism and ZK. Yes. Thank you for your attention. You got the answers right. Okay. So, do you have any question regarding the MetaMask wallet, the UI, all of that, or not? So, I will just show you how to get your wallet address. So here it's in French. Anas just needs to click on recevoir. Yeah, or you can just get it from the top. Yes, both. So when you click here on receive, you also have the option of the QR code. So if a friend is next to you, he can just scan the code without directly entering the Ethereum address. Okay, great. So, a question for you, Anas. Is it the first time that you set up a MetaMask wallet?
No, I did it before.
Okay, you did it before. Okay. And, like, have you faced any issues or challenges while setting up the wallet?
Well, not really, but the first time you see the UI, it doesn't make a lot of sense, like how to switch the network and all. But since you
Yeah.
explained it, it's way
Absolutely,
better for people who
Yes.
it's their first. Especially this, I think it would be nice if you explain to them what is swap and bridge and just a high level explanation.
Okay, so the swap features means to exchange Ethereum to any other token. So you can select, for example, USDC or any other token mainly. So you just need to put how much ETH you have, and then you can swap. And it's also valid for any other coin. So right here we just selected the Ethereum blockchain. For example, if we were on Optimism or any other mainnet, we also can swap to others. So let's try to switch to another network. So yeah, now we have. Can you go back a little bit? I just want to show them something. So yeah.
Okay, here or
No.
before?
Before, yeah.
Okay.
When we switch to Optimism, we have now at the bottom Ethereum on Optimism chain. You see it with red? No. Yes, this
With
one.
the red.
Yes.
This one.
Yeah. This is the logo of Optimism. Okay. We can also talk about the bridge. Is anyone here knows about how bridge works or not? Let me check the chat. So, do you know what bridge refers to? Cross network, okay. Yes, that's right. Can you develop it more, Lapstorm 10? Swap tokens from network to another. Yes. But why we don't use swap directly? Okay, fees. By fees, I think you mean cheaper transaction fees, right? Yes, lower fees, you wrote, okay. It's like a system connecting the Ethereum to many assets to another blockchain. Okay. Okay. I'll wait for one or two replies, then I will answer. Okay. So Omar here have mentioned two bridge examples. The first one is linear and the second is base. That's right. Nadir have gave us a very simple definition. Thank you very much. Okay, so the bridge that we are seeing in MetaMask refers to a blockchain bridge. So it's a tool that enables users to transfer assets, not only tokens, by the way, they can also bridge NFTs or data between different blockchains. So since different blockchains operate independently and have their own standards, bridges help facilitate interoperability between ecosystems. So MetaMask or other wallets integrated the bridging feature that allows users to seamlessly move assets from one blockchain to another without needing to interact directly with the complex third-party protocols. So it connects users to cross-chain bridges that support transfers between networks. So I'll give you some example of bridges. So you can do transfers from Ethereum to Polygon, Ethereum to Binance Smart Chain, and also from Ethereum to other layer 2s like Arbitrum and Optimism. So now, if I tell you why we use a bridge, as I said, first we use bridge for cross-chain compatibility. So we transfer tokens from Ethereum to other blockchains to reduce gas fees or access dApps on different networks. Also to lower costs, so some blockchains have cheaper transaction fees than Ethereum, making bridges useful for cost saving. Also, we use bridge for improved speed because layer 2 solutions like Arbitrum or Optimism offer faster transactions compared to Ethereum mainnet. And finally, we use it to access to dApps and DeFi by moving assets to networks where specific dApps or DeFi platforms operate. Okay. Yeah, that's right. I just said it. It solves compatibility between blockchains. So by that, we mean interoperability. So do you have other questions, guys? I think Omar dropped in the chat this week that he have a lot of knowledge about Ethereum and Solidity. So if you want, you can join us in the stage, Omar.
Before that, Yusuf, I
Yes.
remembered something that I guess when I was a beginner, I didn't know about it, and it's useful. I think it would be nice if you show them how they can create multiple accounts from the same extension.
Sorry? How do they what?
I think how they can create multiple accounts. So they
multiple accounts, you mean?
Just,
yeah. You just need to click on account 1, then add. So for you, it's in French. Ajouter un compte. Voilà. We can try it. So first, you can add an account. Like, yeah.
And that's it.
Yeah, that's it.
It's useful
So
because
Omar
maybe
wants
you don't.
the access.
I think, Omar, can you request to join the stage?
Yes.
Okay, can everyone hear me now?
Yes, we can hear you. Welcome, Omar.
Oh,
If
welcome.
you can,
Thank you.
yeah. If you can quickly first present yourself and.
Yes,
Yeah.
I'm full stack developer for almost 2 years of experience. With, I think, in my end of study internship, I work with Solidity and Ethereum. I'm using MetaMask a lot. In a production environment, not in development environment, using Ganache. That's in a production environment. It goes public. That's why. Anyways, so first of all, when we talk about Ethereum and especially in the part of development for companies or projects, we almost use the security part, not really the net decentralizing thing part, but the security part. At least in my internship. And then when we use the Solidity, I come across to the link of Solidity documentation.
Okay.
Yes. So in Solidity program, it has been from version 0.6 to 0.8, where there is a lot of optimization in using of address and cost fee, especially in gas. Okay, first of all, let's talk about Ethereum and.
Also, if you can remind the audience here what Solidity is exactly.
Okay, so this is programming language. Okay, it's smart contract programming language, and
yes, it's designed for developing smart contracts that run on Ethereum.
Exactly, and deploy it and deployment.
Yeah,
it's not like Python or Java. Okay, that there are some blockchains that accepts you Python or Java as smart contract development thing, but in Ethereum it has Solidity, and almost after Ethereum there are a lot of other blockchain that based on Ethereum core. An example of it is there is an example of it. It's like the hash graph. We use Solidity because it has Ethereum as core of it. Anyways, first of all, let's talk about Ethereum and Ethereum core. When you work with Ethereum, okay, you want to deploy it, you can see the GitHub of Ethereum as programmed with Go. There is the Go version, and there is the C++ version. Okay, the Go version, which is called the Ethereum Go. You can find it in GitHub. Just I'm going to search for it. GitHub Ethereum implementation. Yes, the Ethereum Go Ethereum. You can install it yourself and using it and developing it. Okay, inside the Ethereum Go, you're going to find. Okay, I'm going to share my screen.
So, guys, Omar is just sent the link that he's talking about in the chat.
If you can use it, because I can't share my screen here. I don't know why.
If anyone can give access, Omar, to the screen share, it would be great.
Yes. Okay, I can stream in this channel. Why? Okay, can anyone give me access? Why? Why can't I? Okay, that's weird. I can share my screen, so
Just give it a couple of seconds. Anas is working on it right away.
okay.
Okay.
Can you
If not,
try
Anas,
again now?
you can. Yeah.
Can you try now?
Can try again, Omar.
No, I don't know why. Maybe I have to
Okay,
refresh.
so you want to open GitHub Ethereum Go?
Yes.
Okay,
I'm
can
going
you
to
do
show
it,
them.
Anas? Let's
Yes.
Okay.
let's deep dive together.
So yeah, there's a lot of. Okay.
So what link should I use? It's in
So
the
the final one, the GitHub.
final.
The GitHub one. There's also
Ethereum Go.
the C++ implementation, but it's a lot more complicated. Okay. Okay. Before we talk about communication with Ethereum, we have to have highlight introduction about gRPC as a protocol. So so Ethereum uses gRPC as a protocol of communication. They are the web version and there is the WebSocket version. Okay.
Okay.
There are three types of communication with Ethereum. Everyone going to use or longer. There is the IPC file. Okay. There is the HTTP. So I call the gRPC communication. There is the WebSocket communication. There are three types. Okay. If you are going to see the Ethereum as the repo, you are going to find three important folders in the project, which is the core. Okay, the first one, the CMD, and the S client. Okay, the other files are just for communication with it or to run some code when you are going to deploy inside the smart contract. Okay. So, first of all, when we're talking about the core, if you're going to open the core of Ethereum, okay, you are going to find there is the Go implementation about the blockchain insert and the block validator, which means that each time you're going to make some transaction, this particular file is going to collect all the transactions and it's going to create a block and then verify it, verified by the miners, of course.
Okay.
Yes, that's for the core, and that's the important one for anyone who is going to implement any smart contract and deploy it. Okay, when we're going to deploy it, okay, there are three types of there are two types of address before. They are the client address, developer address, okay, and the client address. For developer address, it's the smart contract address. Each time you deploy a smart contract, there is a transaction, okay, which costs the fee for the client to deploy it. Okay, that's some fee that's going to be extracted. Yes.
Yes.
And is going to give for the smart contract an address. Here we are going to interact with the smart contract with that address, and the Web3 with the Web3, whatever the Web3.js or the Web3.py is going to interact with that address, and that access, yes, with that address is going to give us something, which is what, which is the bytecode of the compiled file. Okay, so after you compile it, of course, the Ethereum will compile the code. He will deploy it and will give you the address. Of course, when you compile the code to really understand what are the functions that are available for the other clients of the internet, there is the API file. Okay, and the API object. Okay, and the APIs will contain the metadata for each function. You are going to deploy it inside the Solidity. I'm
Okay.
going to give you.
Can you please define what metadata is for our audience? Because I'm sure that not everyone
Okay, the
knows what metadata is.
it's like an interface between you and the function.
Yes.
Okay, when you're going to interact with the function inside your application or inside a server or inside computer and going to use it, the metadata will define the function. Also, how many fees you are going to use for that function. I will give you I think I have a project which I deployed and developed a smart contract with it. Just a minute about it because I'm going to find it.
Okay.
Why should I have many repositories now? Where is it? This one. Okay.
We have an answer in chat.
Okay, so I'm going to give you this one.
Metadata. So Droid Z said metadata is data on data. It helps you understand
If you
how you interact with a specific
yes, with a
contracts
specific
company.
function. Exactly, yes. For this link, you are going to find the contract.sol, which is the Solidity version. No.
Yes. .sol.
Yes.
Yeah.
That's all. Okay, I'm going to send the link again. And for this, I send it on the chat.
Okay, I have a question for you. For example,
Yes.
in blockchain, can you give me some example where metadata is used to describe what, for example?
The method is going to be used inside the web3.js or web3.py.
Okay.
Yes.
And what
After
does it describe exactly? If you can give me some examples.
Okay, inside this function, okay, I'm going to have the example that I implemented already. Okay, in the contract .sol, we're going to find the private data. We're going to define the structure, the mapping, the function, and another function, and the construction. Okay, how can I interact with it? I'm going to give you the other link, the other function that I use it for the interaction. Okay, where is it? Views. Adaptation. Web3. Where is Web3? Teacher models, common model is from a statue response. To find it. Web3. No, not here. Models. Not here. Is it?
So yeah, a quick definition for our audience as you're
okay. So when you compile the contracts, or there are two objects. Okay, there's the API. Okay, the interface.
Yes.
And there is the bytecode. Okay, the bytecode will be deployed inside your smart contract. Okay, but the bytecode, yes, the bytecode will be deployed inside your blockchain. Okay, but the API, okay, with the interface, will contain the metadata of each function. I'm going to use the remix. An example, you can get copy code of this code and visit remix. I will give you the link. The remix. Okay, this one, and get started. The minute remix. Ethereum. Media. See this link. This one, and you can open.
Can you tell us first what is Remix ID or?
Okay, Remix ID, it's a platform when you can develop a smart contract and test it if it's working good or not. Also, it gives you some warnings if you are going to going to have some problems where the code or some of your code is not suitable for a suitable version. Yes, something like this. When you are going to compile it, you are going to find two versions.
Yes.
Let's compile it. Yes, Solidity compiler, exactly. Click on Solidity compiler. Yes.
Okay.
You compile it. Yes. Normally, yes, compile and normally compile it. When you compile it, I think you can now publish it. Yes, exactly. Here you can find all of sort of interaction with the function. Okay, and here we're going to have the API function. An example, I'm going to give you an example of what kind of structure after compiling the smart contract, what kind of structure is going to give me. Close. So okay, I'm okay. Yes, no. Action. It this one. This one. Just share my screen. You compile it. The Ethereum node. Okay, there's okay. The API, I'm going to give you an example of the API on the chat. Oh no, there's no API. Why? Compile. What's going on? It doesn't want to compile. Compile. Okay, now it's compiled. Normally I have to some sort of bytecode. This is a bytecode. Okay.
Okay. So
But
Omar
you can see
just pasted the bytecode on the event
yes,
stage
yes,
chat.
that's a bytecode.
Okay.
Yes, that's a bytecode, and this is here is the metadata. It's an empty string. When you're just going to have this type of code. Okay.
Okay.
Okay. So why it does have an empty array? Because there is no function. Okay, that's the idea. But
Okay.
once you have a function, there will be a metadata. I'm just not sure why it is not. There is no metadata inside the project. I'm going to find it very quick. Normally there is some. Normally there is. Okay. Okay. If you can see this link, because I remember that I compiled it. If you can see this link, there's the bin of the smart contract that I built. Okay, which the version 0.6. Okay, and I'm going to send you the API also. Where is the API? And this is the API contract JSON. Okay, these two links, and
Okay.
I'm going to give it the compilation. And this is the metadata of the smart contract.
Okay.
You can see there is an input. Okay, and for each function, what kind of function, which is it is a payable function or not, it is a get function or not, and of course, if each get function has no fee, it's the main concept of Solidity, and each change of block must be payable, and this where the miners will get their rewards. There is also for each function, it will give you it's non-payable or not, and also it will give you the parameters of each function. If does any Do everyone see the? Does everyone see the in the chat?
Yes.
Omar, you can try to share your screen. It works now.
For me, no. I'm going to reload.
Okay, no problem. So we just had the bytecode that you sent and also the metadata. So I think everyone has a bit of insights about Solidity and the terms of Solidity right now. So thank you very much, Omar, for your demonstration.
This link in the chat, I'm going to give you, give to everyone the link of the repo.
Okay, thank you very much.
Why I put everything there. Yes.
Okay, thank you very much for
I couldn't
your
give
demonstration.
any information. Sorry, I couldn't give many information because there is no share screen on the. I don't know
No
why.
problem. Okay. Okay, if we can have Nadir right now. So Nadir previously asked, how does a bridge work and how does it go from blockchain to another? So no one has answered that. Hello Nadir, how are you?
Hey everyone. I know like a lot of people are working on bridges in the team.
Yes.
So I thought it should be interesting for one of them to explain it. But yeah, I will try to do my best and explain it in an easy way. So I think it's interesting to know the difference between a swap and a bridge. So let's take an example, say Tunisia and France, right? Since most of us are from Tunisia. So an easy way to understand it for the swap is basically someone exchanging something in Tunisia in one blockchain. Let's say Tunisia is a blockchain. So when you do a swap, you take a token or let's say a car and you exchange it with a bus. So it's two different entities, but you still do it in Tunisia, right? But for a bridge, when you want to change between something in Tunisia and France, it's another country. So I guess you guys get it. Another country, so another blockchain. So let's say Tunisia is Hedera and France is Ethereum, for example. So if you want to do a bridge, so people just imagine like a bridge is a car moving from, or a boat moving from Tunisia to France, which is not exactly the case.
Okay.
So understand more bridges in crypto. It's not like a swap when you just change it in the same place. To change it between countries, so between blockchains, you have to take a bus in Tunisia. So if you want to bridge from Tunisia to France, you take the bus in Tunisia, you lock it, so it doesn't move. And you create a new bus in France that looks exactly the same, that has exactly the same value. When people hear bridge, they think the bus, let's say, moves from a country to another, from a blockchain to another, but it's not really the case. So I thought it would be interesting to explain that to everyone. And what can be interesting is that people, when they create bridges, so when they lock the bus in Tunisia, in Hedera, what they can do is take the bus and use it. How?
Okay.
So instead of just locking it and keeping it in Tunisia, they can make the bus work. So that's what we call staking. So staking is like, for example, in a bank, you have a saving account. You can take that bus, make it work, and it can earn you money. So bridging is really interesting. So as someone who works on a bridge, you can get money from bridging from one country to another. So you take a small fees, but it's also interesting to keep the assets in your Kotti, in your blockchain, and make it work and earn more like with the assets you have. Yeah, I hope this is a good explanation between swap and bridges.
Okay, I have a question. What are the bridge mechanisms? Can you give us some insights about that?
So if you go more on the technical part, we would say it's locking and minting.
Yes.
So that's it. Basically, you have, for example, swapping Ethereum from Ethereum to Base, layer 2 that you just discussed, the difference between the two. You take the Ethereum, if you want to bridge from Ethereum to Base, which is the layer 2, you take the Ethereum, you lock it on Ethereum, and you mint, so you create a new token, which has the same name in that country, which is Base, and it has the same value. So you really need to trust that this token is the equivalent of the other one in the other country or the other blockchain.
Yeah.
It's really a new token created. And to make sure there is not duplication of tokens, that token, we need to make sure that it's locked on Ethereum. Or like I explained, it's put it in staking. But we need to make sure that it's not used, it's not in the market so people can't buy and sell. Because if it's used other than that, it can create like a conflict. So you have more tokens than it should be. So that's why we talk about security and this kind of stuff. Yeah.
Exactly. Yeah. So you talked about the lock and mint mechanism, but we also have the burn and mint. And do you want also to talk about the rapid versions? Like we always hear about rapid ETH.
You do someone else. Go ahead.
Sorry?
Go ahead, you can explain. Go ahead.
So yeah, when bridging, the original tokens are either locked or burnt on the source chain. So as Nadir said, new equivalent tokens are minted. So here we have, for example, something that is really popular in the blockchain, which is rapid ETH, so WETH. I think that a lot of you have witnessed that. So this ensures seamless cross-chain compatibility without duplicating assets. And that's it. And who can mention, for example, popular bridges? We haven't talked about that. If anyone can answer to this in the chat before closing. What bridges do you know, Nadir, for example?
Most of the time, I use the one from MetaMask, like you just showed. But there's one that is well known. I think his name is Orbiter. It's really a good bridge project. Since we have the more like blockchains we have integrated, the more useful is the bridge project. So yeah.
Okay, thank you very much. Anas the replied wormhole. Okay. So thank you very much, everyone. I think it's time. We had a deep dive into the Ethereum ecosystem. I'll let you, as usual, wrap up a message in on our community chat, and I'll also leave some research topics for everyone who wants to deep even further into the Ethereum technology. So that's it. I want to thank everyone that joined the stage also, like Nadir, Omar, and also Anas for setting up the wallet. I think you can close, Mohammed Amin.
All right, thank you, Yusuf. Thank you, Omar. Thank you, Nadir. Thank you, Anas. Thank you, everyone. Oh, let's. What should I say today? I appreciate you all. Appreciate the shared thoughts, guys. Yes, I think we made this session another solid one. Yes, we're growing, but what I believe the most is we're growing together. That's what is making me happy, especially today. Let's say one session at a time. One session at a time. Okay, so to not make this over dramatic, if you found today valuable, let's not stop here. The Hedera certification is still open and free, but not for long, to be honest. And let's put it that way. It's a great way to turn what you're learning into something real. It's that simple. Check the link in the chat. Yusuf has shared the link already. And of course, the conversation doesn't have to end now or here. We're always around communities like Telegram, our Telegram community, or Discord here. Whether you have questions, as usual, ideas, or just want to keep up with what's next, join the Telegram, stay in the Discord. Let's make the chat more and more growing. And thanks for being part of this. Thank you, everyone. If everyone has to say something, yes, we are ears. Else, thank you. See you next Friday.